this a little quickly for me. Again, emergency power. Okay, winter. It's winter. Important to know. Trying to give you a couple pointers before you get into this season. Yeah. So here we go. Why me? Well, I got a stack of certs, all kinds of crazy stuff, including amateur radio, which has something to do with emergency power as well. And also, hey, I used to be an APC certified reseller, so I learned a bit about that piece of technology. Okay. When I talk about models, brands, the rest of it, I'm not getting paid for it. I'm doing it for illustration purposes. I'm not endorsing it per se. And, you know, this is based on my own experience, okay? I have also from the Federal Emergency Management Agency a certification that says, yes, I understand a bit about generators. A bit. Okay. Emergency power, hey, it's backup power. This is what happens when your normal utility power is out. Now, some people live fully off grid and, you know, you have that. Well, okay, you're in a different league than this. So, and you probably know way more about this than I do, having made that work, right? Well, assuming you just don't live by candlelight. So we're not gonna talk about that. Hey, why? Be prepared, be a Boy Scout, you know. And the question you need to be asking here is, what do I need from me, my sites, and my company? We'll get to that in a second. I'd like to talk about this. Hey, you know, I can do this. If I have to do it fast, it may cost me more. I can cheat. I can cheese on this, right? I can do smaller, cheaper UPSs. Yeah, but my quality is going to go down if I do this, right? Power goes out. You know, yeah, this is straightforward. Someone drives into a utility pole, right? It takes out the power lines, or otherwise takes out the power lines. The equipment failure. You know, I had a transformer in my driveway, buried in a vault, utility, and it exploded. It wasn't exciting explosion. It was, thankfully, but it blew itself up. That took out power to 8 homes, including mine. Natural disaster, other kinds of lines down situations, fires, melting transmission lines, right? That happens in these big fires, right? You lose power because there's the copper wire and all that gets melted. It's hot enough. ETR, estimated time to restore, can be long, hours to days, depending on how remote you are, really, and the scope of all of this. When you're the only outage, they can be reasonably quick. When you live really remotely, sometimes it could take them, though, from the depot to your house can take a couple of hours to get there. So, you know, that's a factor in all this. What's your risk? Yes, a historic risk, old poles. Former Secretary of Energy, a lecture I was at one time said, hey, poles have a 40-year expected lifespan. The average age was, I think, 41 or 42 years at that point. So that meant most poles are beyond their expected service life. And we saw that, like the Paradise Fire, if I remember, the explanation was, yeah, you know, these old poles failed. Yeah. And then we have historic problems with weather, right? If you're in Tornado Alley, you know, you're along the Gulf Coast or in Florida, you know, you're worried about hurricanes, even up the Atlantic coast to a degree, that, yeah, drought, right? So things get nice and dry. You have these summer fire seasons, right? And those are historic. We have some things like utility problems, and I can speak to one of them. There was a transmission line problem that fed Sand Hill Road up in Menlo Park, where a bunch of venture capitalists are. That was causing a major power outage, taking out a bunch of VCs and Stanford Linear Accelerator. Now, California, we're seeing right now, that's unprecedented and that is criminal. It really is. But you're living with it, right? You have a business in there, and now you send a bunch of people home with COVID. This is something you have to deal with, right? And then climate change, I'm going to say it, diss me all you want in the comments, whatever, man. We're getting, weather's getting crazier, storms are getting more intense, droughts are getting drier. That's causing a lot of issues. So things like excess heat, right? It gets hotter, it means more air conditioning's running, means more likelihood we have these mandatory brownouts or blackouts because of this grid's overloaded. Right? So these are problems you got to deal with. Why is it an IT problem? Well, because everything is an IT problem. Not quite true, but hey, your equipment runs on electricity, and you know, IT without electricity is sort of like tech. It's T, because there's no information. You can't get out of the machine because it hasn't got any power, right? So yeah, it is kind of your problem. It's best if you can partner with your facilities, because oftentimes, assuming you're large enough to have something like a facilities group, that they're typically going to be dealing with the bigger power issues and engaging electricians. So having a really good working relationship with your facilities folks is great. And you want to be on the conversations too when they're thinking about specking out things like generators. Emergency power is that you're an important part of that, right? So hospitals, yeah, we want to keep ventilators and all that good stuff running, and all the tech is an important part of it as well. Okay. Scale could be a campus, could be an office, could be a single office, could be a home office, especially now with COVID, right? A lot of people working from home. I would hope that, like, if I have offices, you know, I'm thinking about it, like if I have office in Reno and office in Las Vegas, same state, but I would really hope that, like, we don't have a single power outage takes out both those locations. I'm hoping, but things crazy. 2020, so yeah, they just all go down. How do we mitigate? So here's some ideas. Can we have multiple utility providers or tap off multiple grids? Well, I don't want to answer that question. Talk about UPS, we're talking about generators, we're talking about solar, and we're talking about solar plus battery. Okay, I am talking a little fast. You can always slow this down in the replay. Can we multiple providers or grids? Well, okay. As far as I know, I don't know anywhere where there's multiple transmission provider lines, different, like completely different systems, because it's inefficient. Don't have multiple utility poles and that, you know, from different competing providers. I mean, that just doesn't seem like it's going to be efficient. So I don't think you can do that. Yes, I know you can sign up, hey, I'm getting my power, I'm paying such and such for the power, and it's being transmitted over the municipal utilities lines. You can sometimes do stuff like that, but redundancy there is sort of meaningless if it's things like a transformer failure or a line, you know, pole going down, lines going down. There's, yeah, there isn't another set of poles, or isn't another set of lines going into your complex. This multi-grid thing, I was told that a high-tech company in Silicon Valley had managed, because they were right at the edge of two grids, to get feeds from both, paying apparently a huge amount of money. And then they had this giant switch, that mechanical switch that they would throw to go power off of the grid. But the lines came in on the same pole, and apparently a delivery guy took the pole out. That's what I'm told by a guy who worked there, but he wasn't there when it happened, so it could be this is just, you know, apocryphal. But it's still a fun story. Certainly, you know, if I had the offer and it made any sense, I might go for it. But you know, that's the other piece of this. You got to think about if I'm feeding off, you know, the east side of the campus from one grid and the west side comes off the other grid. Awesome, right? Because then at least I probably don't share a pole. At least you never know. Okay, UPSs, these are just basic. You're doing it. You know, no UPSs, you're nuts, right? That they also work as power conditioners as well, so they keep from blowing your gear. So you want to do this. Now, first thing to know, a VA is not a watt. And you go, wait, but what isn't a volt times an amp the definition of a watt? Yeah, but VAs are about apparent power. When voltage and current are out of phase because of capacitive or inductive reactance. You can look at all that stuff. That's not the important part. That what it looks like we're delivering is not the same as what we're actually getting out as usable work. There's a power factor is what this all comes down to, and it's hard to find. I've had a lot of trouble finding that information from manufacturers. Number I see usually somewhere around 0.7, so about 70% of the VAs translation of watts. So figure about like and they have these power calculators on their website sometimes. APC used to have one, so you can put in all the watts for your different devices, and it'll come up with a this is what size UPS we recommend. Figure about 70%, so about 1,200 watts out of 1,500 watt UPS or 1,500 VA, excuse me. Now, and we're not going to do that scale anyway. Okay, UPSs are not created equally. One of the differences is some of them are designed, they take the DC power in, or take the AC power input, they convert it immediately to DC, and then reconvert it back to AC to come out the other end. That seems crazy. You're like, wait, if you know anything about electronics, there's loss in both those conversions, right? And that's true. There's going to be heat generated out of both those conversions. The reason they can do that, though, is this way. Sometimes I'm having your incoming voltage will vary. And if you're monitoring this stuff, your UPS actually keeps track of this. it'll be above certain thresholds and below. Every time it hits above and below, the UPS kicks online, takes you out of battery power to deal with the over or under volt situation. In these situations, what they can do though is they can simply, if the voltage is dropped too low, it draws more current. And because you're re-rectifying at the other side of this occasion, that you, I can deliver a real consistent voltage on the output, right? And if it was something with an over voltage, I'm just drawing less amps out of it. So the considered advantage, they don't tap the batteries as long, and we're gonna get back to battery life. We'll talk a little bit more about that. So Liebert is one that does that. That's one of their selling points. They're like, is why I want my Liebert. APC has some models that do that, not all of them do. Sizing. Don't buy just what you need. You want to buy bigger. The bigger means more runtime for your load. Because if you go into those calculators, typically they'll show you, okay, yeah, you can buy this one, you get 5 minutes of runtime. I talk about this runtime thing, but this bigger one, and half the time what happens, you buy it, you put it in a rack, and you're like, well, I only have half the rack full, and I only need like I can run this up a 3,000 VA unit. And then you're gonna fill the rest of the rack out. Now you gotta stick another UPS in, and you're doing things like you're putting the weight higher up in the rack. You don't want to do that. UPSs you want low. Part of it in that rack shakes. You should be bolted to the floor. If it's the top of the top of the rack's unsecured, as that thing swings around, it has a lot more force, because force is mass times distance for your torque. It's going to have more torque by having the thing higher in the rack. You don't want to do that. And then, of course, I've also got to deal with, I want a single UPS, probably. Okay. 208 versus the 110. Yeah. Most devices have auto switching power supplies. Check before you do this. You can run 208. Anything above 3,000 VAs is going to be 208 anyway. And the PDUs, you can buy 208 PDU. You use a slightly different cable. You have the C13, C14. You can look these up, what they are. Use a little different. You're not using that NEMA 515 like you're used to. It's fine. But you'll get a bigger UPS out of it. Okay. But like I said, check your gear, make sure it can run on 208. If you do need to use 110, that APCs typically use a step down transformer, so they have to take 208 out and then convert down to 110 for your devices. Liebert has some of the packages on their smaller UPS that they can do both. Because they use an L1430, which is basically bonding two 110s instead of at the panel, which you normally do. The bonding, it's really at the plug level that you're dealing with this, right? And so they're getting those two feeds, and they can natively output both 110 and 208. It's kind of nice. Runtime, yeah, more is better. And I'll talk more about that when we get to generators. A lot of people buy these things, they're like, oh yeah, it should run for like an hour, right? And you're like, no, it's gonna run like 5 minutes, 10, maybe 15 if you're lucky. Unless you buy like these, you buy a bigger unit, or you buy a bigger unit and you buy these extra battery packs that daisy chain off this thing. So, but really to get like hours worth, you're talking probably something, it's gonna be a huge part of a 42U cabinet. Okay, think about that. So you have this cabinet that's like 7 feet tall, half or more of that is gonna be batteries. You're gonna get a decent runtime out of it. When you just have like the one little thing, I've got a little like 1,000 VA unit next to my desk that's about that kind of big. Yeah, that's gonna go five minutes, maybe 10. And I just get a couple laptops and some displays right on. I don't even have the printer on it. Okay. Battery life and maintenance, they do not last forever. Figure 3 years. They're gonna have to be replaced. The more you have to tap the batteries, there's only so many charges any battery can take before they stop holding a charge. Every time they tap into the batteries, you're also reducing, because a lot of them are lead acid. There's only so many times it get recharged before it just, each time it's going to take a little bit off that runtime, If you have a lot of units, and particularly if you're similar, if you're really in this crazy situation where you have a different one for every closet, is a really good reason for that. If not, if I can have consistent, I'm going to have some spares. But I'm not going to carry a lot of spares, because even sitting on the shelf, they have a life. They are degrading as they sit. So think about that. And then heat. You have some closet. Oh yeah, it's a sauna in there. It's like 85, 90 degrees all the time. Yeah, what's happening to UPS? Those batteries are overheating. They're starting to bulge out. And what's going to happen is that Eventually they're going to fail, and you can't even get them out of the unit because they've expanded to the entire space. You're going to try and get them out of the crowbar. You're probably going to break the EPS. So control your heat. You got to keep the heat into something reasonable. 70s, mid 70s, right? I'm talking Fahrenheit because I'm American and I'm an idiot and we don't do Celsius because we're just that way. Get over it. Sorry. Generator, fixed versus portable. I think it's kind of obvious. Can I tow it behind a truck, or whatever, or is it, in concreted in rest? Okay. There's portable ones that can generate a huge amount of power. In fact, during the big power problems of the early 2000s, some folks in Montana were using old diesel locomotives as generators. So that's portable. As long as there's a railroad track to go with it, that's portable. Environmentally terrible, but versus fixed. Okay, requirements. You can't have them. You can't be connected to the grid and running a thing. Two problems. One, you're backfeeding power, which may hurt a utility guy trying to fix the thing. And the second thing is that, everybody who still has their breakers on is going to be trying to suck your power. So you got to have this. They're very serious on the major facilities. Are very serious about this. For a house that's built for a generator, even portable one, which this house is, and I'm filming from right now, there is a plug on the outside of the house that feeds directly to the main breaker panel. Main breaker panel has a service disconnect that it's got a mechanical. If the main breaker is on for the utility power, you cannot turn on the power for the generator feed. You cannot do it. So you've got to have the service disconnect. Anything that requires a fixed one, permits. And you'd be surprised sometimes. I was at a site near San Francisco Airport, and the FAA, I don't know, excuse me, it wasn't the FAA, it was the airport had jurisdiction as well over permitting. That they can say, no, that we don't want to do this. It's possible to interfere with our, safety and equipment. So just so you know, there's a lot there. The other thing too, it's got to run outside. You can't have it. It's got to be outside because there's carbon monoxide out of there. It will kill you if you try and run it inside, right? So they're like, oh, I'm going to put it in the garage. It's storming. No, it's going to kill you. Don't do it, right? They're noisy as all heck. Your neighbors will hate you. This may be a barrier to getting a permit because you have this office and it butts some residential neighborhood, and they get wind of you and they may be trying to kill your permit. Okay. There's some environmental issues because you deal with fuel, right? Fuel spills, oil, whatever. These can cause you some issues. And you also have emissions, right? So it's the newest ones. I understand a lot of jurisdictions are requiring these much better filters on diesel generators, right? It used to be they were pretty dirty. And it's like, no, you got to have, and you got to have something like UPS. There is apparently something else that isn't necessarily UPS. Doesn't have batteries. It's got some flywheel. I haven't seen these things myself. I've heard about them. But you need that because the generator does not immediately come up to speed, even if this is all fixed and automated. A portable one, typically, like in my situation, okay, power goes out. I've got to go. I'll roll the thing out of, open the garage door manually, roll the thing outside, shut my breakers down, fire up the generator, connect up fuel because I'm using external propane tanks, connect up the generator, get the thing running, get the thing plugged into the house, let it run for a couple of minutes to stabilize. Then I've turned all the breakers off on the panel, and then main feed is off, the utility feed is off, breakers are on for the generator. Great. Start turning on the breakers one at a time, not letting the full load hit it. It can damage your generator. With these automated ones, they're going to have some automated transfer switch to do this. It'll be pretty seamless, but it will take them a little bit for the generator to fully spin up the speed to be able to take care of your load. So it's not like the moment that thing turns over that you're like, yep, I'm taking the full power, no blip. Not going to happen. And you have to detect the outage as well. So you got to have something like UPS. Quality is terrible, right? So if you put an oscilloscope, which it can visualize electrical signals, they're usually terrible, right? Especially the smaller ones. It's really jagged power. It is not clean at all. Your equipment may not like it at all. So, I've had to turn the sensitivity of the UPS off. Otherwise, what it was doing on the generator, it was kicking in and out. I'm like, okay, so I'm feeding through more lower quality power to my equipment. It's not a great thing, but on the other hand, we just would lose the whole network if we, because this is home office, right? We lose in COVID, that we lose it if we did that, right? Refueling, you got to be careful, right? So if you're dealing with, there's a lot to think about in this one. So in my case, I'm using those large barbecue-sized propane tanks. So refueling is fairly straightforward. I just need to keep swapping tanks. I have 6 of them. That'll last me like a day and a half. Okay, on a 4-bedroom house with a lot of stuff turned off. So it's no miracle. But if you got like gasoline, you spill it, you've got some environmental problems. It's there's safety stuff about refueling and all the rest of it. So you may actually, some things may require you to run the generator off, turn the generator off, let it cool, and then refuel it. And I know one of the sites with a generator, we used to have a rule that the moment the generator kicked in, we were on the phone ordering up fuel. And I think I talked about that a little bit in another slide, but if I do, we'll just kind of repeat. Because here's the deal. It would take the guy a certain amount of time, the fuel company, to get a truck out to us with more fuel. So we immediately said, come and retank us. And then the plan was, since we were hosting customer devices, that we would then have this schedule where it's like, okay, and then you're going to come back out in this many hours and this many hours and this many hours. I'm just going to do this, right? So there's some challenges about keeping fuel, right? And I think I do cover this in another slide. I'll come back to it. Okay, solar. Well, the basic thing is, if I'm just solar, one, my power is all over the place as the sun goes behind clouds, and the change in the day and the rest of it, it's not quite on. There's even passive systems that help the panels turn to keep facing towards the sun to try and maximize power. But legally, if I'm connected to the grid and use solar, I have to shut off my solar when the power goes out, because I don't want to backfeed the grid and injure a utility worker trying to restore power, right? But you can have batteries, right? So there's those Tesla Powerwall things and stuff, and they'll sell some of these things. They're awesome to do this thing. They may have sort of built-in UPS to make this work. It is kind of UPS, really. If they can do the switch over cleanly enough, then you may not have to have separate UPS. It's probably a good idea anyway. But thing is sizing. In a large house, I had 5 kilowatts up on the roof. It didn't take me as far as I thought it would. So, if you talk to your professional, and professional's like, well, you can run with this. You probably want to go, can I go more? Right? And think about the battery, start talking about, they should be able to pull some data about your usage, and we go, well, okay, your batteries will last for this long. Okay. And okay, so yeah, I'm gonna get into this here. So plan ahead. Generators will not be available when you need them. So big disaster, first they're going to things like hospitals or others that are more critical than you are. So if you haven't already planned for this, forget it. No, I'm gonna take it back just a little. If you really can and you already have the setup, fine. But yeah, fuel supply may be an issue. Go to the gas station if you're using gasoline powered. They may not be able to pump because, yeah, they have a pump. They need electricity to be able to pump the fuel out of the ground. And they may need to run like the point of sale stuff. So you may not be able to get fuel. Now, with a business, if you have like a fuel company and they have trucks and all that, maybe that they can do, you got to work this through with them. You got to find out that, they're going to charge your PO, so they don't need to worry about running a credit card, and they have a way of getting fuel out of the ground, out of their underground tanks, even with the power out, right? And then I kind of brought this up earlier, how long it's going to take them to get there, right? So if I got 5 minutes, I can't even get out of my garage in 5 minutes, right? By the time you throw your shoes on and go to the car, pull the release so you can push up the garage door without power, 5 minutes are gone. I need more than 5 minutes. So you got to think all that through. And you got to think about this, well, what do I need the power for? The less I need to power, the longer my fuel lasts, longer my batteries last on the UPS, okay? And you also need to know this because you want to know what your capacity is. There are some things in the house. Maybe you don't want to, maybe you don't need to power the gift shop. Maybe just forget it. No gift shop, right? But yeah, you probably want the kitchen because people still need to eat even when the power's out. Okay. You want to plan. You want to figure out what you're going to cut off services in a big industrial setup. You're probably going to have those red outlets, and then you need to have some rules that say, hey, red outlets are not for things like your personal space heater because you get cold. No. You need to have rules about what those things are used for, and then have a test plan. And I mean this, UPS should be tested regularly, the generator should be spun up, make sure it's still working. You may want to run a drill and see what happens when you go, switch over to your generator. Does everything happen the way you expect it to, right? So those are good things to do. So this is my talk. As I hope it's useful, right? So use the power calculators on the UPS vendors websites if you need to. Figure out what you got. Figure out what you're going to need. And frankly, there's some of the larger, like for the house, if I was going to do this, right now it's like, yeah, go on my desk. There's one in the back where the rack is with our equipment. If I own this place, I would probably have red outlets, a big UPS somewhere, powering those, fed by that feeds a panel. I'd probably do all that kind of stuff. I've seen places that I stick a UPS under every desk. It's really expensive. And keeping all those batteries up is just nuts. If I have that kind of bad power, I want to think a better solution, right? So, check on the website, learn more. You can reach out to me. Maybe we talk through some of this stuff, right? Around the generation stuff, yeah, you're gonna need a real electrician. You need to talk to you about that, who specializes in this. And your electrician hopefully knows, is in your jurisdiction, so they understand what your permitting requirements are, right? Okay, I got a YouTube channel where you found this thing. You're gonna interact with me. LinkedIn is a great place. I pretty much will take any LinkedIn invitation, pretty much. And I'll chat with people, and if it's like, hey, I'm not interested, I'll let you know. Or if I can't help you, I'm like, hey, I don't, that's outside my league. You want to ask me detailed electrical engineering questions? I'm not licensed for that. So I'm like, hey man, you got to talk to an electrician. I'll talk to an electrical engineer. Okay. And then with anything, hey, you want to hear something you think I may know about, right? Because hey, look at that list of certs, man. You're like, tell me about BGP, buddy. I may not be the best guy at BGP, but whatever, I'll do my best, right? So feel free to suggest in the comment section. So there we go. Hope this was useful, and I will talk to you soon.